Hello everyone. Today in this video we'll be discussing further on whole numbers, and today's topic is properties of whole numbers. So there are different properties of whole numbers that are being used while carrying out the different operations, and thereby it helps in the simplification of the problems on whole numbers. So let us begin. What are the properties of whole numbers? First property is the closure property. Now here you can see the whole numbers are closed under addition and multiplication but not under subtraction and division. Now this sentence means that the closure property satisfies only when the operation is addition or multiplication, but not when it is subtraction and division. According to the closure property, when we add or multiply any two whole numbers, the resultant number will be a whole number. But it fails in the case of subtraction and division. Now we can see that with the help of some examples. So you can see in the first example, 4 and 5 both are whole numbers, and 9 is also a whole number. Here also the same thing. Now why I have taken two different examples? Here what I have done is I have added a small number with a large number, and the resultant number is a whole number. In the second case, what I have done is I have added a large number with a small number. Means I have seen both the cases, and the result that I got is the whole number. So in the case of addition, the closure property satisfies. Similarly, in the case of multiplication as well, I have done the same thing. What I have done in the case of addition, just the operation has changed. Here it is also a whole number. Again you can see the result is the same, a whole number. But what about the case of subtraction? In the subtraction, when I have done this thing, that when I have subtracted a small number from a greater number, the result is a whole number. But the opposite is totally different. You can see when I have subtracted a greater number 4 from a smaller number, then the result is a negative integer. It is not a whole number. So the closure property fails here in the case of subtraction. Similarly, in the case of division, the same thing we have done. We have divided a greater number by a small number. The number is a whole number. But here, when we take the opposite case, when we divide a smaller number by a greater number, it is a fraction. It is not a whole number. Similarly, when you're done with 0, the result is similar. Here, when the greater number is divided by 0, it is undefined. There is no value for it. So I hope closure property is clear to you. Moving on, next property is the commutative property. Now, here also, the commutative property satisfies only in the case of addition and multiplication, and not in the case of subtraction and division. According to the commutative property, when we add or multiply any two whole numbers in either of the order, in any order, the resultant value will be a whole number. It will be clear as if you see an example. You can see here 4 plus 5, this is one order, and when we reverse the order also, 5 plus 4, the result will be same as it is, as well as it is a whole number. Similarly, in case of multiplication also, the same result we have got, that is a whole number. But what about subtraction? This is one order, 6 minus 2. If we reverse the order, 2 minus 6, the result is not a whole number. So here commutative property fails in the case of subtraction. In the case of division also, same examples I have used. Division also it fails. When we take 0, is the same thing. So commutative property also holds in the case of addition and multiplication only. Clear? Moving on to the next property, that is the associative property. Here also again the same thing. These properties are, you can say, the repetition. that always it holds in the case of addition and subtraction, multiplication, but not in the case of subtraction and division. In associative property, here the order, they have a particular order. The order is, if you take consider three whole numbers a, b and c, then according to the associative property, a plus inside bracket b plus c will be equal to a plus b inside bracket plus c. This is the associative property order. You can see with the help of example. If you consider three whole numbers a, b and c, that is 4, 5 and 3, a plus inside bracket b plus c, we got this much value, and then is equal to a plus b inside bracket plus c. Clear? The result is same. Also both are whole numbers. So it satisfies addition. In the case of subtraction, it does not satisfy. You can see here clearly the same thing we have done. A minus b minus c inside bracket is not equal to a minus b minus c. Clear? In case of subtraction, in case of multiplication, this holds. Clear? In case of division, it does not hold. The answers are different. Now moving on to the next, that is the distributive property of multiplication over addition. Now the distributive property is used mostly when there is two operations used, that is both the multiplication and the addition. Say for example this 4 into 5 plus 8. If I told to find this value, what mostly we will do is we will first do the operation on this bracket, inside the bracket, and then multiply with 4. Yes, obviously we can do that. But what about if you are asked to do the distributive property or use the distributive property? So according to the distributive property, if it is a into b plus c, then according to the distributive property, a into b plus a into c. So this is the distributive property. So that's what we have done here, and then we got the answer. And even if we do in that earlier way, that 5 plus 8, 13 into 4, we will get the same answer. So distributive property holds in the case of whole numbers. Another example I have given here, same thing I have done here. I considered 7 as a, this as b, and this as c. Then a into b plus c will be equal to a into b plus, since there is a plus symbol, a into c. Clear? The result is same. And even if you do 4 plus 2, 6 into 7, it will be same result. Now, these properties, I hope these are clear to you. There are also some other properties other than these 4 properties. Let us see that. One is called the additive identity. 0 is called the additive identity for whole numbers. Identity means we get back that same thing. Let us see an example. If we add 0 to any number, say 5 plus 0, it will be equal to the other way around. If we reverse the order also, 0 plus 5, we will get back same number, that is 5. So that's why 0 is called the additive identity. When we add a number, add 0 to any number in any order, then the result is the same number. So it is called an additive identity. Next is the multiplicative identity. 1 is called the multiplicative identity. When we multiply 1 with any whole number, we get back that same whole number in any way. Either this manner we do or this manner. Any order if you follow, the result is the same. So I hope you all have understood the different properties of whole numbers. Please go through your textbook, and then try out other examples as well. In the distributive property, you might be thinking why I have not done in the case of subtraction. Distributive property, in case of subtraction, will it hold or not hold? This is your job now. You can try it out and then find for yourself whether the distributive property holds in the case of subtraction or not. The process is same, that is a into b minus c, it will be this time. It will be a into b minus a into c. You can try it out at home and see, does the distributive property of multiplication over subtraction, does it hold or does it doesn't hold? Does it satisfy or not? You can verify your answers also, just like we have done in the case of addition. So that's it for today. Thank you and have a nice day.